I acquired this interesting device. It's for amateur radio, and here's a wand and a coil, and by the looks of it, it is probably from the 1920s or 30s. But the most interesting feature about this is the tuning indicator. It's in Braille. You set the tuning indicator, and behind there is a variable capacitor. So by what I can figure out is this device was specialty made for a blind amateur radio operator. So he could take this this wand here and put it near a tank coil in a radio, and then he could determine what frequency he's on by setting it with the Braille settings. I don't read Braille, but it probably is a graduated scale of numbers. Now, there's a light bulb socket there, and that is probably so it could be used by sighted people. And there's also on the top is a socket for headphones. So I would imagine that the blind person would have heard a click or a buzz, depending on the tank circuit, when he knew he was in resonance. So by adjusting the dial, he adjusted it for resonance. So I'm going to open this up and have a look at the inside. Oh, by the way, before I do that, I'm going to check and see what frequencies this is resonant at using a modern antenna analyzer. I hooked the antenna analyzer up to these two binding posts here, and I took off the wand, and the lowest setting is 2.775 megahertz. The highest frequency, the highest setting on the variable capacitor, is 3000 megahertz. Since the coil on the top looks like it's changeable, I guess originally this unit came with interchangeable coils, and you could set it for whatever band, ham radio band you wanted to set it for. The box is a well-constructed, I don't think it's manufactured by a factory, but probably was made by a craftsman who was also a ham. He did very nice work. The box fits together very well, and you just remove the screws from either side of the box, and it comes apart very easily. It comes apart. It fits quite tightly, actually. And there we are. There's the insides. Inside the box has a real 1920s look to it, with a big, well-made variable capacitor and a vacuum tube. And it's got a ceramic socket for a light bulb, a couple of resistors, and a capacitor right there. You can see right down there. And there we have an old-fashioned socket for a earphone, like a telephone socket that they'd use in an old-fashioned switchboard console. So I went through the circuit, and this is what I came up with. It's basically the wand couples. It's like a small coil that couples the RF signal into this coil at the top, the changeable coil. The input of the coil is 2 microhenries, and the resonant part of the coil is 12 microhenries. The maximum part of the capacitor is 270 picofarads when it's fully meshed. But you'll notice that only one part actually turns. The other part is adjustable, but it doesn't turn with the shaft. So it's obviously meant just to, this is like a trimmer pod, I guess. And it tunes just a portion of the band. So the main, because you're talking about, you're just above the medium wave band, you're at 2.7 to 3 megahertz. You need a large capacitance. So that's what that larger capacitance does. It just, you can adjust it though. It does move. It does move down here. But anyway, that smaller capacitance just trims it to the right frequency. Now, this tube, I'd never seen a tube like that before. It's called a BH tube. And it's a cold cathode rectifier, meaning it doesn't have a filament. So you have a high enough voltage across it, and it will conduct and rectify. So what you have here, you got this tuned circuit here, and you've got a very high impedance detector circuit across it. 1.5 megs, 3.6 megs. That's so it won't load the circuit down when it's at resonance. Now, if you're not using the bulb, you have this this capacitor to isolate it. Allows the AC, or pulsating DC, to go through. And you'll need to have both an earphone in the circuit. You don't need the light bulb if you're using the earphone, but you always have to use an earphone. You can have both if you want to. So when the tank circuit reaches resonance, it the wand couples enough of the signal into the tank circuit, which produces voltage multiplication and ionizes the gas in the tube, and you'll hear it click. Or if it's modulated, depending on what part of the, what part of the radio that you're taking you could be coupling the signal from the output circuit, and then you'd hear a voice if you were speaking into it. But this is most useful. You could use it for tuning up the antenna too, I guess. But you'd probably just hear a click or a kind of a hum as it reached resonance, and that's how you'd figure out it was tuned up. This tube, I believe, starts conducting at about 80 volts. So it would take, you'd have to hold the wand very close to the tank circuit in order to get that much voltage. Now, this BH tube is interesting. As I said, it's a cold cathode rectifier. It doesn't need any filament. And it's a Raytheon tube. And this apparently was the first electronic device that Raytheon came out with. And these tubes were marketed through the National Carbon Company, which is Eveready. An interesting thing about dating this device, I looked up these tubes. They're still quite common tubes. And this particular tube is after 1927, because after 1927, they didn't have the little tit on the top, where there was a little bump on the top where the air was evacuated from the top prior to 1927. They were made from 27 to, I think, 37 or 39. They're made for a long time, but the ones after 1927 are these ones here. And right here, they're smooth. After 27, the tube was evacuated from the bottom. So that's how you always know these. You can date these tubes if you have another device that used it. The device was this particular tube was used in battery eliminator power supplies to charge up batteries, but also they were used when people had battery radios, like farm radios. They would use these battery eliminators using this tube, and they would hook it up to their various voltages that you need for farm sets. So anyway, this is a very interesting device, and maybe one of these days I'll use it. I'll see how it works.